Okay, today we're looking at lesson 10. We're going to be solving some multi-step measurement word problems. Okay, making sure to use the RDW process to solve them. So, number one, we have Paula, and Paula's time swimming in the Ironman triathlon was 1 hour, 25 minutes. Her time biking was 5 hours longer than her swimming time. She ran for 4 hours, 50 minutes. So how long did it take her to complete all three parts of the race? Okay, so that's why it's called the triathlon, because we have three parts to the race. So we have swimming, we have biking, and then we have running. So we have an exact time for the swimming. Okay, so her swimming was 1 hour, 25 minutes. Okay, now biking was 5 hours longer than her swimming time. Okay, so we have a longer bar. And we know that this was 5 hours, this part right here. Okay, and then the running time we have an exact measurement for. So we see that we have 4 hours, 50 minutes. Okay, now again, looking back at the question, how long did it take her to complete all three parts? So we're trying to find that measurement right there. Okay, so first thing we see that we know the swimming time, we know the running time. What we need is the biking time. So we see that biking time is 1 hour, 25 minutes plus 5 hours. Okay, so that's going to equal 6 hours, 25 minutes. Okay, so now we have an exact measurement for all three events. Okay, so now when we go to add, now we have 1 hour, 25 minutes plus 6 hours, 25 minutes plus 4 hours, 50 minutes. Okay, so now we can start combining our like units. Okay, so for minutes we see that we have 25, 25, and 50. Okay, well we know that 25 plus 25 is 50, plus another 50 gets us a total of 100 minutes. Okay, now we add up the hours. So we have 1 plus 6 is 7, plus 4 gives us 11 hours. So we have 11 hours, 100 minutes. Okay, but we know we can take our 100 minutes and turn it into 1 hour and 40 minutes. So our total now is 12 hours and 40 minutes. Okay. So her time for all three events was 12 hours and 40 minutes. Okay. All right, moving on to number 2. Okay, we have Nolan put 7 gallons and 3 quarts of gas into his car on Monday, twice as much on Saturday. We want to know the total amount of gas for both days. Okay, so we have Monday, we have Saturday. Okay, so we see Monday, 7 gallons, 3 quarts, and on Saturday it was twice as much. So we have 2 of those, and we want to know the total. Okay, now one of the things we notice is that Saturday has 2 sections the same size. Okay, so we don't need to find Saturday and then add to Monday. What we can actually do is save us a step and just notice that we have 3 bars that are the exact same length. So what we can do to find our total here is 3 times 7 gallons and 3 quarts. Okay, we can just multiply that by 3 to get our total for both days. Okay, so we know that that's 3 times 7 gallons plus 3 times 3 quarts. Okay, so that gives us 21 gallons and 9 quarts. Okay, Well, we know from our gallon picture on the front of the book that we can take our 9 quarts and convert those into gallons. Okay, 4 quarts are in a gallon, so that means we have 2 gallons and then 1 quart left over. Okay, because our 8 quarts would give us 2 gallons. So now that gives us a total 23 gallons and 1 quart. Okay, so pretty quick and easy if we use the multiplication. So the total amount of gas for both days is 23 gallons, 1 quart. Okay? All right, moving on to number 3. Okay, we have 1 pumpkin weighs 7 pounds, 12 ounces. A second pumpkin weighs 10 pounds, 4 ounces. A third pumpkin weighs 2 pounds, 9 ounces more than the second pumpkin. What is the total weight of all 3 pumpkins? Okay, so we have 3 pumpkins here. We have an exact measurement for the first 2. Okay, so our first one, 7 pounds, 12 ounces. Our second one is a little bit more at 10 pounds, 4 ounces. Now we see that our third pumpkin is a little bit more than the second pumpkin. Okay, so we know that it's 2 pounds, 9 ounces more. Okay, so we would put that right there. Now again, the question is the total weight for all 3 pumpkins. Okay, now we can go through and start adding this up. So our first pumpkin we see is 7 pounds, 12 ounces. Second pumpkin is 10 pounds, 4 ounces. Now, if you notice, our third pound has 2 sections on it. So what we're going to do is we're going to add up those 2 sections in our total equation. So now pumpkin 3 is 10 pounds, 4 ounces plus 2 pounds, 9 ounces. Okay. So if you look at our equation now, we have pumpkin number 1 here, pumpkin number 2 here, and then we're solving pumpkin 3 right here. Okay, so now we can go through and start adding up our like units. Okay, so for ounces, we have 12 ounces, 4 ounces, 4 ounces, and 9 ounces. So if we add those up, okay, we see that we have 29 ounces. Okay, now if we add up pounds, I see that I have 10, and 10 is 20. 20 plus 7 is 27, plus 2 more is 29. So we actually have 29 pounds, 29 ounces. Okay, now we know that there's 16 ounces in a pound, so we can turn this into 1 pound. We have 13 ounces left over. So that gives us a total of 30 pounds, 13 ounces. Okay, so the 3 pumpkins weigh 30 pounds, 13 ounces. Okay? Alright, so moving on to number 4. Mr. Lane is 6 feet 4 inches tall. His daughter Mary is 3 feet 8 inches shorter than her father. His son is 9 inches taller than Mary. How many inches taller is Mr. Lane than his son? Alright, so this one's set up a little bit different, so we have to really look carefully. Okay, so we have Mr. Lane, we have Mary, and we have his son. So going back into the problem, we see that Mr. Lane is 6 feet 4 inches. Okay, now Mary is a little bit shorter. So we know this section right here is 3 feet 8 inches. Okay, now we have the son who's taller than Mary, but shorter than the father. Okay, and we see that the son is 9 inches taller than Mary. Okay, so you can see 9 inches right here is a little bit more than Mary, but we're still less than the father. Okay. Alright, so now this is where it gets a little bit different. We need to know how much taller is Mr. Lane than his son. So we're trying to find that amount right there. Now looking through all of this, it might look a little bit complicated because it's an unusual tape diagram. But if you notice, we're really only focusing on this part of the tape diagram. So we'll cover up parts of it. So we're only focusing on this section of the tape diagram. Okay, so I'll walk you through what we just did here. Okay, we know that the difference between Mary and Dad is 3 feet 8 inches. Okay, now the son is a little bit taller than Mary, so we're going to take off the 9 inches. But we can't do 8 inches minus 9 inches, so we're going to convert one of our feet into 12 more inches so that we have enough to subtract. So now we can do 20 inches minus 9 inches, and that gets us 11 inches. And then we have our 2 feet left over. Now, our question here is, this is why it's always important to go back into the question. If we notice, our question says, how many inches taller is Mr. Lane than his son? So we know that Mr. Lane is 2 feet 11 inches taller than his son, but we need that in inches. So we're going to take our 2 feet 11 inches, okay, and we need to convert that now into total inches. 2 feet now is 24 inches. Plus our 11 inches, we get 35 inches total. Okay, so Mr. Lane is 35 inches taller than his son. Okay, so with these word problems, again, it's so important to make sure you're reading the question carefully, make sure you're underlining and circling in the question, and model it out with the tape diagram.